This screencast is the first in a two-part series that demonstrates how to use SymmetricDS Pro Manager to configure a synchronization scenario. We'll assume you've already installed SymmetricDS Pro. If you haven't, please see the SymmetricDS Pro installation screencast for additional information. To start the SymmetricDS server, click Start, All Programs, SymmetricDS Pro, and Run Server. This will start up the root instance of SymmetricDS Pro. Once the SymmetricDS server is started, to start the management console, click Start, All Programs, SymmetricDS Pro, and Management Console. This will bring up a web browser that points to the SymmetricDS Management Console. Once SymmetricDS is started, it lets us know that the database we configured has been found and asks us to confirm those settings. So we'll do that and hit Continue. The next thing the SymmetricDS Manager asks is whether we want to use one of our pre-configured profiles. A pre-configured profile is a synchronization scheme that is pre-configured for a specific application and/or database structure, such as a specific point-of-sale application or other application. We have several pre-configured profiles and plans to add many more. For this example, we'll configure things ourselves by clicking No Thanks, I'll configure things myself, and clicking Apply. The next thing the SymmetricDS Manager asks for is a user ID and password for the administrative account for the SymmetricDS Manager. This ID and password will be used for subsequent logins to the manager. Once we specify those, we're asked to log in using the credentials we supplied. The first screen you see in the manager is the dashboard, along with a common menu structure across the top. We'll come back and revisit the dashboard a little later. The 5 menu items across the top allow you to navigate throughout the manager. The SymmetricDS menu item takes you to the dashboard, the screen we're currently viewing. The Configure menu item takes you to a set of pages that allow you to configure your SymmetricDS implementation. Configuration is setting up the synchronization definition for your scenario. At a high level, what data moves where. The Manage item allows you to manage a synchronization configuration that's already running. Things you can do via these screens include registering nodes to participate in the synchronization and scheduling, starting, and stopping symmetric jobs that facilitate the synchronization activities. The Explorer item allows you to look at data that's being replicated via the system, including incoming and outgoing data, as well as any errors that may occur. And finally, the Help item allows you to look at version information and installed SymmetricDS extensions. We'll visit each of these menu items in additional detail, but for now, let's get started by configuring SymmetricDS for our synchronization scenario. For our example, we'll be synchronizing a very simple retail scenario, which includes a store database and a home office or central database. Retail companies typically need to synchronize pricing information and other master data information to a store, and sales transactions back from the store. That's the scenario we'll demonstrate. As you can see, I've created 2 MySQL databases, Central Office, which represents our home or central office database, and Store, which represents a store. The table structure I've created is very simple. It includes a store table, an address table, consumer, item, and then transaction and transaction line item. One of the questions we get asked frequently is whether the database structure needs to be identical on all the nodes being replicated. The answer is no, but in order to keep our example simple, I've configured things that way for now. You can see that the Central Office database also has the same tables, address, consumer, item, store, and transaction line item. To begin configuration, click on the Configure menu item. The first thing we'll configure is node groups. Frequently in your synchronization scenario, you'll want the same synchronization rules applied to many endpoints or nodes in SymmetricDS terminology. As an example, in a retail store scenario, you may want transactions to be routed to the central office. You don't want to specify synchronization rules by individual store, but by all stores or a grouping of stores. A node group allows you to define those groups. Much of SymmetricDS's functionality is specified by node group and not an individual node. This makes it much simpler to configure large-scale synchronization scenarios. For our sample, we'll create 2 node groups. As you can see from this screen, this box on top shows all of the node groups that currently exist. The central office node group was actually created for us when we installed SymmetricDS Pro. The bottom details are the details of the highlighted node group from above. We'll create a second node group called Stores by clicking the New button, giving the node group a name, and then an optional description, and then clicking Save. Now that we have our node groups set up, we'll want to specify how those node groups interact. This is where node group links come into play. Node group links allow us to define the synchronization relationship between node groups. For example, the Stores node group pushes data to the central office. There are 2 types of links that can be established. The first is pushes to, and the second is waits for pull from. Pushes to is pretty straightforward. It dictates that a node group will push its data to another node group. Now we'll set up a link for the stores to push data to the central office. When I save the link, the manager lets me know that there is no router set up for this link and asks me if one should be created. We'll click OK and let SymmetricDS Manager create the router. We'll discuss this step in more detail when we talk about router configuration a little later on. We also want data to flow from the central office to the store, such as item and store information, so we'll create a second node group link for this. For this interaction, we'll use our second link type, waits for pull from. There are several advantages to this link type, including allowing nodes to determine when they're ready to pick up changes, as well as some better options for performance and load balancing. So we'll set the source node group up as the central office, and we'll specify the link type as waits for pull from, and we'll specify the stores. In this scenario, the central office will capture changes that need to be sent to the stores, and it will wait for the stores to pull those changes when the stores are ready. We'll click Save, and similar to the previous one, the SymmetricDS Manager tells us that a default router doesn't exist for this link yet, and asks us if one should be created. We'll click OK and let SymmetricDS Manager create that link. Now that we have our node groups and our node group links configured, we need to start thinking about the specific tables that we would like to have synchronized and how those tables are logically grouped together. This is where the SymmetricDS concept of channels comes into play. A channel represents a collection of tables that can be enabled, prioritized, and synchronized independently of other channels. Data synchronization is defined at the table level, but those tables are grouped together and assigned a channel to help control the flow of data as a collection. As you can see, there are already 2 channels that come pre-configured, config and reload. The config channel is used by SymmetricDS to synchronize its configuration with all the participating nodes. The reload channel is used to provide initial load capability, which we'll discuss a little later. Let's create a couple of channels for our replication scenario. The first channel we'll create is for our master data flowing from the central office down to the stores. We need to provide the channel a unique name. We'll call this one master data. Then we need to determine whether we want this channel enabled. Enabled means data will be synchronized. Disabling the channel means data won't. The processing order field allows us to prioritize one channel over another. As you can see from our pre-configured channels, any configuration data will go first, reload data will go next, and then we can set processing orders for our other data channels. It's a good idea to space out your processing order numbers, 50, 75, 100, etc., such that if you decide to add a new channel in the middle of an existing one, you have room to fit it in. The next configuration we need to set for the channel is how SymmetricDS batches data. SymmetricDS batches data together before it's synchronized to another node. The batching algorithm and max batch size parameters determine the boundaries of how data will be batched. There are three options for the batching algorithm. We'll start with the transactional batching algorithm. This option dictates that batches will map directly to database transactions. For example, if two rows are transactionally committed together from a database perspective, they'll be batched together and synchronized together to other nodes. If a single row is committed to the database, that single row will be synchronized to other nodes. With the transactional batching algorithm, the max batch size setting is ignored. The batch size is always based on the database transactional boundary, and each batch always represents a single transaction. The non-transactional batching algorithm has the exact opposite effect. In this scenario, database transaction boundaries are ignored. SymmetricDS will batch rows together until there's no more data to be sent, or the max batch size parameter is reached, and then send the data to participating nodes. The default batching algorithm is the best of both worlds. In this scenario, SymmetricDS batches data up to the max batch size, but also ensures that no database transactions are split over batch boundaries. We'll specify default for our batching algorithm and leave the defaults of 10,000 rows for both max batch size and max data to route. Now that this channel has been configured, we'll click Save. Now that we have our master data channel configured, we'll create a second channel for our transactional data. To create the second channel, click New, specify a unique channel name, and we'll keep the rest of the parameters the same, and then click Save. In this screencast, we've demonstrated how to set up node groups, node group links, and channels. In Part 2 of the Configuration Screencast series, we'll discuss how to set up routers, triggers, and the associations between the two.